So he is Viktor Kuzev from London, UK. He's a parametric and computational design expert, and he will be talking about the BIM and the visual programming in the BIM world. Yes, Victor.
Hello, so my name is Viktor Kuzev, and I'm currently based in London, helping Grimshaw to make the expansion of the Heathrow Airport. And actually, I'm also running this YouTube channel called Revit Experiments, and there is a website that I've put up also called revitexperiments.com. So this is what I'm doing. And I'm going to talk today about computational design, and in particular Dynamo and its use in BIM. So what is computational design? It is the application of computational strategies in the design process. So what does it mean? It means pretty much automation in all kinds of ways. So since algorithms tend to be precise and overall better at performing a task on a large number of objects, we can actually use this for automating repetitive tasks in the design. Like, for example, on these pictures, here you can see repetitive patterns that you can imagine. Like if you are to model this piece by piece, it's going to take a long time. And also we can precisely calculate location and orientation of objects. Again, like for example, imagine panels that should be placed and oriented in a certain way, or for example, moving panels that should follow the daylight location. And yeah, so performing geometric operations on thousands of objects, like it's pretty much automation in the modeling process. Like you can imagine, like I guess you've all modeled to a certain extent, like even in AutoCAD or SketchUp, you know, like for example, you have a bunch of beams and then you have to cut them with some geometry. You can actually automate that with the help of computational design. And of course, applying mathematical logic on thousands of objects. That means, okay, if this beam is that big, or if it is of a certain time, only then cut it with something. So what is computation in BIM? So since, as you've already talked about BIM a lot, you know that BIM is not just about modeling geometry. BIM is about informed geometry, metadata, and attributes, parameters. So loading multiple families into multiple Revit files, for example, is one of the tasks of a BIM manager in a company, and that could be automated with the help of computation. Like usually when setting up templates, or for example, there were some projects in development and now we want to swap all the families we used to in the conceptual design with actual furniture, for example, and those families then come from a manufacturer. Then we want to swap all of them, and that could be done with the help of computation in multiple files at the same time. Automatically linking Revit or CAD files. I can actually quickly show something I put up recently on my YouTube channel for automatically linking CAD files in Revit at once. So it's pretty much works like this. We just press that button. I'm going to try to speed up the video. So we press a button, then we can see that the script is running, and there is this window that's opening here. So if you have worked with Revit, you might be familiar with these options, but these are just the options of how the linked DWG files should be linked. Like Should it keep the colors, the positioning, import units? This is the standard panel. Yeah, actually this is the standard panel, and here we have all the options. But instead of doing it one by one, we can just paste in here directory on the server or on the local computer, and then it's going to link all the files that are in this directory to our project. So that saves a lot of time. Let me go back to my presentation. Oh. And what other applications of computation in BIM we have? Like we can automate the creating of sections and plans and placing them on sheets. We can automate view and file naming. For example, like if we have set up a bunch of sheets in Revit and we want to change their names to match certain project standards or company standards, we can automate that. And populate data to shared parameters, automate creation of 3D objects, calculate cost, calculate speed. So what is Dynamo? Dynamo is a tool for visual programming, and it looks like this. Instead of actually coding to make the automation, we just create the logic with these boxes. So it's pretty much like the block schemes in program. Even when you write a program, you first make a schematic presentation of it, and visual programming is actually avoiding the actual writing of code. And it's used not only in Dynamo, it's used in many contemporary software, like for developing games and for rendering. Here, this is an example actually in Maya, if I'm not mistaken. This is visual programming in music. So this is actually creating sounds. This is Unity. It's a game engine. And this is maybe the closest thing to Dynamo, which is Grasshopper, a visual programming tool that runs on top of Rhino. So how does visual programming work? It's pretty much as a recipe for making food. Like we have our inputs, which are going to be the ingredients in this metaphor. Then we have different functions and operators. Okay, so we take some of the ingredients and then we put them in a blender. Another ones we do something else. Then we mix them together. We do some operations, and then the output is our meal. So the idea is that each time we have the same ingredients, we're going to get, and we apply the same functions and operation, we're going to get the same meal, pretty much. And if we change, of course, some of the parameters, some of the ingredients, then we're going to get something that is slightly different. So why Dynamo? Well, one of the biggest benefits of actually having a visual programming tool like Dynamo is that it can help even small teams to develop their own computational tools without the need of hiring developers. And it's also more flexible since, okay, if you hired someone to write a script for you, then every time you actually want to change something, because projects are different, they have different requirements. Then for another project, you might need something slightly different. Then you have to get back to those people and make them create another version of that plugin. It expands the capabilities of Revit for exchanging document data, geometry, or attributes. Attributes are pretty much parameters in Revit. Or if you've worked with GIS data, you know that GIS data also has attributes, heights of buildings, types of buildings, etc. Saves time, but more importantly, it allows for better informed design. It expands Revit's capabilities of analysis and optimization. So I'm mostly talking about Dynamo running on Revit, but Dynamo also exists as Civil 3D plugin, and it's open source, so somebody with coding experience can actually make it run on top of other software as well. And it also exists as a standalone application. And as a standalone application, it can work with Autodesk Formit, and if I'm not mistaken, Autodesk Fusion 360 as well. It contributes for achieving better design, because the more information we have in the beginning, in early stages of design, about what are the consequences of what we are designing, then we can adjust that design in early stages to match the requirements better. It automates mundane, boring tasks, like, for example, changing 100 names of the views, or linking 100 CAD files. It's easier to use and more versatile compared to traditional computational solutions, and I mean code. Optimization. If I have time, I'm going to show you something really cool with optimization. But yeah, this is actually pretty much what I've been interested into currently, optimization with genetic algorithms. So this is not only us adjusting parameters, but it's an algorithm that adjusts parameters till it finds a solution to multiple problems and a number of good solutions. And then we can just pick one of those already filtered good solutions. And it is the next step in BIM. Some people say it's the future, but it's actually being done now. In Grimshaw, we are using this quite a lot. So who should use Dynamo? Ideally, it should be someone who is well educated, who has good knowledge about Revit. Because this is actually a quote from one of my friends. I want a Dynamo script that works while I'm just sipping on my coffee. And it doesn't really work that way, even though it would be good. So yeah, the problem that I've encountered while teaching Dynamo to people is that many of the people are really hyped about Dynamo right now. It's something that, oh, Dynamo can do this, Dynamo can do that, Dynamo is magic. And those people don't really have the good foundation of Revit knowledge. So often they try to do something in Dynamo that has a pretty good out-of-the-box solution in Revit. And also, at other times, because of their lack of experience and knowledge in Revit, they can't really do something really simple in Dynamo. So ideally, Dynamo should be taught to people that already have good skills in Revit. I mean, maybe not top expert skills, but at least they've been working Revit for like a year or two. They know how to use worksets, they know how to use shared parameters, and they know how to make families, how families works. So how to successfully use Dynamo? First of all, it's a matter of quality training. I mean, you can, even though you can pretty much learn everything from YouTube nowadays, still it's a lot better and a lot faster if you get someone to explain it to you and your team. And especially like if you have a particular problem to solve with the help of computation, then often you can't really find how to solve that problem online, and it would be better to just get help from someone. Reuse of created Dynamo graphs. That means when we create Dynamo graph is kind of the term graph, script, pretty much the same. Like, since script implies coding, scripting, text, we tend to use the term graph when talking about these Dynamo solutions, because it's more like a graphical representation. So reusing them is really important. I mean, if we only create a graph for one task and then it just goes away, sometimes it's not worthy doing it. So that means creating a library of Dynamo graphs and nodes, and creating an index and user guide for using those graphs and nodes by people not trained in creating scripts. What do I mean by that? Okay, I'm writing scripts for solving something in the project. Excuse me. And I know how that script works. And I use it in the project. And then if I just put it somewhere on my computer and nobody knows what I've been doing, it's not optimal. Like once I use the script, the graph, I can actually make it better. I can add comments. I can put it on a certain spot in the server where we have like company graphs. And I can also create a user guide of how to use that graph. Okay, maybe a PowerPoint slide or any kind of document that explains how to use it. So it says, okay, take that input, this part of the graph is doing that, that part of the graph is doing something else, and this is the output that you can expect to get from this. So this is one example. This is for a project that I've been working on in Sweden. So this is an adaptive component in Revit, and that adaptive component is really complex. Like pretty much everything is parametric here. All the geometry depends on parameters. And the goal was to automate the design of a great number of small bridges. So they all had to be the same types of bridge, like that look like this. I know that they're not beautiful, but they're in the countryside, and they had to be cheap and to work. So the engineers have some tables that say, okay, if the bridge is 10 meters wide, then the thickness should be that much. If it is also like 15 meters long, something should change. So we had that thing as data pretty much. And we also had a location curve, alignment as I believe is the correct term. And that alignment was spread in really like tens of kilometers. So we had coordinates on that alignment, and these were just like 1D coordinates. What does that mean? It's a number that tells you on what distance from the beginning of that alignment curve you place the bridge. And I also have that in a video here, even though I don't really have the 15 minutes to show it in detail. But yeah, so in this example, what it is shown is that actually Revit's capabilities of creating parametric models can be combined really well with Dynamo's capabilities of pushing data and automating stuff. So pretty much like modeling tens of different models was automated to become just a single click of a button, which was a great success for us. Oh, went to the beginning. Sorry about that. Okay, then if I'm going to show any more videos, I'm going to do this after the presentation. And another thing, a part of the same project, sorry, were those kind of bridges. So this is something different. This is a bridge that is long several kilometers don't remember the exact number, but we also had tens of those, and we wanted them again to be cheap. They had to be concrete bridges because on top of them are running high-speed rail, high-speed trains. So it should be really stable. We couldn't really use like suspended constructions and metal because of the vibrations that they create. So again, we wanted an automated workflow because we had too many of those. And we couldn't really spend the time to model each of them separately, like with different data. So here, they're actually modeled in Dynamo and then imported in Revit. And again, it was automated. Here, it was not a single push of a button, but still, like we were getting the data from Civil 3D, directly pushing that into Dynamo. So these models were really detailed, like they had all the correct slopes in the lanes of the bridge to make it work. And then the piers, the supports, they were also placed with Dynamo to the correct heights, so they match the topography and the underneath surface of the superstructure. Placing and orienting facade panels is another great application of computation and Dynamo. I haven't personally worked on this project. One of my friends has developed it. It is for a building in Paris. The company developed this building is called Snohetta. It's a company based in Norway. So here, there are several points that I want to talk about. The initial conceptual model was done in Rhino. Why was it done in Rhino? Is Rhino better to do this than Revit? Probably not, but just in many companies that deal more with concept design, Rhino is the go-to tool for design. Then with the help of Grasshopper, which was the other tool that I briefly mentioned at the beginning, that geometry was panelized. And the data for these panels was exported to Dynamo from Grasshopper in terms of vectors, points and vectors. So then these points and vectors were pushed into Dynamo, and Dynamo placed Revit generic components and adjusted their angles so they match the surface. And it had that information from these points and vectors from Rhino. So this is the facade model in Revit. I don't know if you can actually see my mouse pointer or no, but yeah, in the top right corner of the screen, it is the facade model in Revit. And in the bottom left corner, it is the full combined model in Revit where the facade model is linked in. So next thing, placing an orientation of beams. This is a geodesic dome, and it's a structure made popular by Buckminster Fuller in the 60s. It's a really popular structure for creating domes because it is really lightweight and stable. It's a shape that is really geometric. I mean, it comes from an icosahedron divided and projected onto a sphere. So the description of that shape could be done mathematically. And that's where Dynamo comes in. I mean, if it can be done mathematically, it's very easy for a computational design tool to make that structure and to parameterize it, because once we had that basic mathematic for creating that shape, then we could create different sizes with different numbers of dividing these faces here. And then we placed those beams, and these beams all had to be oriented to the center of the dome, as you can see here. So the structure works nicely and looks nicely. And That was pretty easy to do with Dynamo, actually. We just got the vectors and with a little bit of math, managed to rotate the cross section of the beam so it looks to the center. And then we placed those, as you can see it in that image on the right, joints. And there were three types of joints depending on if the joint is in the middle of that hexagon shape here, or if it is in the middle of pentagon shape. So you can see there are these hexagons and pentagons in the geodesic dome. Automated coping of beams. So yeah, here we have trusses in Revit. And I don't know if you've worked a lot with Revit, but when you just create a truss and apply the different types of beams, it looks ugly. It doesn't look properly. And then if you want to cope those beams, then you have to go one by one pretty much to extend it and then to select the other one and say cope. And this was one of the first tasks I've used Dynamo for back in the day. Actually, I did this in 2014. Anyway, so another application of this is creating a curtain wall in Revit from an image. So that means just getting that raster data, which an image is, getting the pixel, getting its brightness. So the brightness of white is 255, and the brightness of black is 0. So we get that data for all the pixels, and then we map it to a parameter of a curtain panel in Revit. So let's say like when the brightness is the maximum, we would like to have a big opening in that panel. And then when the brightness is minimal, we would like to have no opening at all or a small opening. So it's just, again, a matter of math and solving things. And we can just, with the push of a button, change a picture. It is really cool. And I've seen many of those facades actually on parking buildings, because of course for parking buildings, we don't have so much requirements for lights. It's not an office. So parking buildings tend to have some imagery on their facades. Unfolding walls. This was a tool I developed for one of my clients 2 years ago. And they wanted to create an unfolded drawing of walls that look like the bottom left corner, and to show their intersection with topography in Revit. So with the red line, you see the intersection on one side of the walls, and the green line is the intersection on the other side of the wall. And actually, I really want to show you this now. So even though it was, it's going to be the initial version of it here. Yeah, actually, this is the full instructional video. It's 25 minutes, but I have a shorter one. Which is that thing. So pretty much we just select the walls. We select the walls, then we click run. And then we get a drafting view with the boundaries of the walls unfolded to a flat surface. Okay, let me go back. Sorry about that.
Victor, can you hear me?
Okay, let me continue. I just got a message from Adnan.
Yeah, Victor, am I audible to you?
Sorry?
There are a few questions from the participants.
Okay. Do we have time so I can finish this and then we can have questions at the end?
Yeah, sure. Okay.
Yeah, I just want to continue with some examples. So this, for example, is a product specification made with Dynamo. At the top left, you can see these are all the families used in a project. This is a project in Stockholm. It's a medical laboratory. And with Dynamo, we managed to export all the data to a preset made in Excel, and then just print all of the sheets to manage to get a nice sheet like what you can see on the right of the screen. Automatic key plans. It's another application that I've used Dynamo for. So in this case, we had an apartment building where the apartments were modeled and then grouped into groups in Revit, and then these groups were copied because this is what the team was using to create the apartment buildings, just like groups, and copy those groups. So from those groups, we made these key plans automatically, which is what was handled to the clients. Okay. Questions and answers, I guess.
There's one question on your WhatsApp. I have shared it.
Yeah, so I have a doubt on Dynamo. What is the impact of Python scripting in Dynamo? What level of Python knowledge is required to work on Dynamo scripting for BIM professional? Well, I have to say Python is not really required to use Dynamo because the idea of Dynamo is using the nodes and not really coding. But then if you know how to use Python, it can expand the capabilities of Dynamo even more. For example, here, let me see. Okay, dimensions. Yeah, I've done a lot of scripts for dimensioning that are made in Python because it was actually better. Like for example, right now, the dimensioning tools in Dynamo lack some functionality, so you have to use Python to make something more complex. But then people like me who develop nodes and who can code actually make these libraries in Dynamo. They are called packages. So you can search for a package online and you can install a package. So even if something is not readily existent in Dynamo, there are many packages like if you actually type in Google Dynamo packages, there is this site called dynamopackages.com. And if you're going to use Dynamo, I can advise you to just like install all of these here under the category of most installed. And then in some of the packages, there are nodes for dimensioning that are not existing in the out-of-the-box Dynamo.
Any more questions from the audience?
Yes?
Yeah. Victor.
Victor, you mentioned about automatic key plans that can be generated in Dynamo. Can you elaborate more upon that?
Sorry, what was the question again?
The key plans,
Yeah, the key
automatic key plans that can be generated in Dynamo. Can you elaborate?
Yes. Yeah, actually, I have a video about those key plans. Here it is. It is a mock-up project, but it was later used in a real project, as you can see in the presentation. These were the key plans for the actual real project that we used it on. But before using it on the real project, of course, I had this mock-up project, and this is where the video is from. So playback speed. Yeah, here I'm showing that the apartments are just groups in the floor plan. And then with the script, it selects all the groups. It filters out the unique groups because, like, for example, one group can be placed in many places, but then in the key plan, we want to show that group only once, and then we want to show where it could be found. I don't know if I can zoom here. Like, this is the apartment, which was a group in Revit. So the script made that legend, and which shows where we can find that apartment on the plan of the building, which is here. It also placed that arrow to show where the entrance of the apartment is. It also placed these texts that are actually the name of the apartment, because the name of the apartment was the name of the group of in Revit. And then the sheets included the graphical scale, data, and here this is just saying that this is a draft. And also how it works, it created a number of views in Revit, and it modified the crop region around the group. Then it placed that view on a sheet, and also placed the legend on a sheet, and it put these names accordingly, like text notes. Then another script that we run was to order the views on the sheets, because the first script was just placing those views in the bottom corner of the sheet. And how the second script works is we get one of the sheets, we order everything as we want to, then we run the script, and it does this automatically for all the other sheets as well. So we do one, and then we populate that order to all the others. We had in that project, we had 74 key plans, 74 sheets that look like this.